Hey there, hope you're all doing well today. It's Thursday, just before a long weekend, so there won't be any new work tomorrow, and there will not be an assignment associated with today's video. So we're going to have two videos today. I'm going to do a very short introduction, and then I'm going to give you a video that's going to show diffraction gratings on the internet. I would have done something very similar to those demonstrations if you were here in class, because that's one of the demos we do in this unit. Our diffraction grating is different. Everybody has a pair of glasses on instead, and it's pretty interesting to see. So hopefully we'll catch up on that another year. Certainly Physics 30 will do it again if you get there. But we're going to watch this quick video today, just to introduce spectroscopes and those spectrum, and then we're going to, like I said, we'll have a second video to watch as well. Now, in terms of topic 3, we'll get into it in more detail on Tuesday, but what it's showing us is how these spectra, and we're going to introduce 3 kinds of spectra: continuous, which is just a complete rainbow; bright line spectra, which are just a series of bright lines; and dark line spectra. Dark line spectra look like a rainbow, except they have a bunch of dark lines put in. We'll show how those compare really quickly today. So why are we studying those when it comes to space? Well, these spectra have 2 very important technologies that we use with them. Number one is to tell us what is the composition of distant stars. So by looking at the light coming from distant stars, we can run it through a spectroscope, and we can tell what gases are in the atmosphere of that star. How does it differ from our sun? We can also tell if a star is moving towards us or away from us. So its general location using the spectrum and something called the Doppler effect. So starting Tuesday, we'll get into more detail on that. Today is just a slight introduction to these. So let's see where we go. So how do we make a rainbow? So we get rainbows when it's raining out and sunny out at the same time, because the water droplets act the same way that traditionally a triangular prism does. So a triangular prism is made of glass, and the glass is at different density. So light has the very unique property that when it enters a more dense medium, it slows down and it bends. But each wavelength, each color, red, orange, green, blue, indigo, violet, each of the colors of our Roy G. Biv, they bend at different rates. So the red bends the least, and down here at the blue or the violet end, it bends the most. So that's unique for this property, which is called refraction. Again, not something you have to know about for this course at this time. I know you did take this back in the elementary years, probably grade 2, 3 maybe, and then you may have done some more in junior high with it. So you've got a triangular prism here making a rainbow. So that's one way to make it. But we have another way as well. Another way is using a diffraction grating. So you notice that when the prism bent the light and broke it down to its colors, the red, green, and blue represented here, the red bent the least, and it only went on one side of that central path that it was coming in. But a diffraction grating, and I'm going to explain what that is just in a second, diffraction grating bends as well, but we get an actual rainbow on both sides of that central original equilibrium line. But notice the difference. In the case of the glass and refraction, blue bent the best, red refracted rotten. But with diffraction is also bending, but it's due to different properties. Red actually diffracts the most, and blue bends the least. So blue bends best, red refracts rotten, diffraction definitely different. So it's the opposite. But it also gives us prisms on, or gives a spectrum on both sides. So we can make a rainbow or a spectra, that would be our more scientific word for rainbow, 2 different ways. We can use it the old traditional way, like a raindrop, or a triangular prism, which actually uses refraction, or we can use diffraction grating. And that's what's going to be demonstrated today on that video. So exactly what is a diffraction grating? Diffraction grating is a device made up of thousands of closely placed slits used to produce a spectrum. So it looks like a piece of clear plastic, but inside are actually a whole series of lines, dark and bright lines, thousands per meter that go across. You can't see them, they're so tiny. However, when you put light in front of them, you get that spectra produced. So you're going to see that very well today in today's video. So we're going to talk about more on Tuesday, 3 different kind of spectrum. So this is your standard rainbow. It's called a continuous spectrum. It just goes complete Roy G. Biv. Over here we have what's called a bright line or an emission spectrum, and that just has certain bright colors. On the other side here we have what's called a dark line or an absorption spectrum. It looks like the rainbow again, except there's going to be dark lines. So the bright line, also called emission, continuous spectrum, and then the dark line, also called absorption. So just 1 or 2 more things to do over really quickly. If you take the dark line spectrum for a certain gas, for a certain element, every different element on the periodic table will have a different pattern of dark lines. But if you compare it to the same gas for the bright line, the lines match up perfectly. So the bright line or the dark line spectrum, every one is different for every element. So whatever gas this might be, all 5 of these lines must be present, or it's not that element. And that's how they're going to identify different gases. But we'll get more into that Tuesday. Today's just an introduction to it all. So that's it for today. Watch the next video. It's again about 5-6 minutes, so no assignment today associated. Have a good one. Take care.